In the last short video, which I call reliability 1, this is going to be reliability 2. In the last short video, we went through and just did some basic split half in Chromevox Alpha. This video, we're going to go back over and look at some of what we did with that. We're going to look in SPSS and Excel. So just to get us started, as a recall, we have our first split half, which was on 1, 2, and 3, compared to the subgroup for 4, 5, and 6. And the second time we did groups for 1, 3, and 5, the odd ones versus the even. So in Excel, I put in the same data. I have 6 items, same 6 items, and these subtests are odd versus even. A is odd, B is even, and the total value across individuals. So some of the work we do this semester will be in SPSS. We can certainly do some, we'll do some in Excel, and we'll do some item analysis later on in other software programs as well. But each one is a tool with great capabilities, and here we'll take advantage of some of what Excel can do for us. I'm going to go to reliability 2, which is set up for us. What I'll have you notice, and I believe I posted this online for you, for those students in my class. If you're not in my class and watching it, you're welcome to learn. But for those in my class, we've talked about alpha and the Spearman-Brown prophecy in class. And here we can see we can calculate in Excel. I've calculated out means and standard deviations, and also a correlation between A and B. So the correlation between A and B, I just simply took and did default correlation in Excel. If these aren't familiar to you, CORREL is the correlation in Excel. I'm not going to go ahead and teach that in this video, but we'll maybe talk a little bit about that in class or in another video. So I've just done a basic correlation in Excel, and then I'm adjusting that correlation with the Spearman-Brown formula. Because each subtest has a size of 3 and the total test we care about is a size of 6, this value is multiplied by 2. And that's the same Spearman-Brown formula we talked about in class. We're taking that correlation, multiplying it by 2, and then dividing by 1 plus that correlation value. And that gives us our new adjusted value, which is our reliability, or measure of reliability. This index we also calculated in SPSS. We got the correlation value, double click, correlation value of 0.342, and we got a Spearman-Brown adjusted for 0.510. That rounding issue, I'll go ahead and double click on this box and peek in here, and we can see that that was just a rounding issue. The two values are the same. I also have this set up now. Same exact formula, same everything set up, except subtest A is just like subtest A from our first analysis we ran in reliability video 1. This is items 1, 2, and 3 compared to items 3, 4, and 5. Those subtests that they aggregate information. I conduct the correlation, then I do the Spearman-Brown formula. And when we did SPSS before, we see 0.82 for the correlation between the two forms and a Spearman-Brown coefficient 0.901. That correlation, in some ways, is a reliability, is also a form of reliability, in that if we really believe these two subtests were just truly separate tests measuring the same thing, we could just do that correlation and come up with one of our coefficients. Maybe we're assuming the forms are equivalent, type parallel forms that we've talked about in class. But here, the Spearman-Brown's formula is an adjustment back to the size of the original test, so from 3 to 6. We also calculated out alpha. Alpha is, again, our average of all those possible split halves. 0.804. I'll go ahead and click back on Excel. And I have gone in Excel and done, not by hand, one might say, but sometimes when I think of Excel, I think about calculations by hand, because I have to get down to a lower level to actually build the analysis. And here I'm taking a ratio, so I have summed all of the variances, and I have the variance of the composite as a total. And to calculate Cronbach's alpha, or KR20, depending, basically the same formula, I'm taking 6 divided by 5, which is the number of items divided by 1 minus that number of items, 6 divided by 5, times 1 minus, and this is that important kind of conceptual ratio, the variances of each thing individually by the variance of everything for the total score. And that's one of the ways that we can calculate out Cronbach's alpha. Of course, another way is just we let SPSS do the work for us. And we've also seen the equations in class.